All right, so this one is on dividing radicals and rationalizing radicals, okay? This is just simply figuring out how to simplify even further than where you get to at a point when you're working with radicals, okay? So dividing coefficients, then you're going to use the quotient rule, and this is the quotient rule that can go either way. It's reflexive because it's equal to each other. So if you have nth degree, that means I can have nth degree as a very big radical sign with a divided by b as a radicand. You can rewrite it that way, or if you're given this, nth root of a over b can be broken down into nth root of a over nth root of b. It works both ways, okay? So the coefficients are the numbers that are in front of the radical signs. You can treat the radical signs almost like an x, okay? Almost like a variable term. So the numbers that are in front of it are considered to be whole numbers that are already simplified. And get to that point where you have simplified everything within the quotient rule and the coefficient, you simplify further to get to the lowest term of that radical. So here we go. What's 12 divided by 2? So easy. We're going to go ahead and write that 6 as a whole number. Okay, because 6 over 1 is same thing as 6, right?
Yeah.
What's square root of 160 over square root of 5? We're going to put it into one big house of 160 over 5. What's 160 divided by 5? 32 is what that is. So we have 6 rad 32. If I have a square root with no index written out, what degree is that? 2. So I need 2 of identical type to make one group to simplify. So do I have 2 of the same type here? Let's see. 4 times 8, 4 times 2. So it looks like I have 4 as my identical 2 of a kind. Yes? So what do I do with that 4? It comes out, and what do we do with that 6 then? We multiply with the 6, and then we're left with 2 inside. So 6 times 4 is 24. Square root of 2. Done. Okay? We put it into the lowest term for the rational part, as well as the radical being simplified. We're done. Okay? If you ever encounter an answer key that didn't look like what you had, you might have to rationalize the denominator or simplify it further. Okay? All right, so let's keep going. Am I recording? I think I am. That orange dot, I think means I'm recording. Huh? Yes, everyone's voice that can be picked up by the iPad will be recorded. Okay? All right, here we go. Why do you want to interrupt it? 'Cause then I'm going to just stop recording altogether. All right, so 36 divided by 9? 4. Lucky number 4. Here we go. So we have 4th root of 1,250 divided by 2. And because I've done this for the 3rd time now, I already know what that is, and it's 625. Anybody know the root of that perfect square, 625? 25. 25 times 25 gets me 625. And I need what kind? 2 of a kind or 4 of a kind? 4. So I can break this into 5 times 5. 5 times 5, leaving me with a root of 5. Because I have 5 4 times, I need to make groups of 4, right? So what do I do with that 5? Multiply with the 4 that's already outside. Then I have anybody left over? Nope. Then we just go straight into writing it as simple as 20.
So once there's nothing inside the square root,
They disappear. We lose use of that rad. How you doing? Why is your computer open? Why is your computer open? Uh-huh.
So because we already simplified 625 as much as possible, that's because 1.5 is
do you have an accurate packet? I just realized I'm on the wrong one. I don't think I was here. Oh no.
You were taking a test and I gave you handed it to you as I was taking your test, if you remember. I really hope you didn't, because that's a lot of paper. All right, here we go. So the quotient rule allows us to write this as a single radical. Isaiah, did I answer your question?
It's just because just simplify as much as possible.
Yeah. Yeah. So we got square root of x cubed y to the 9th power over square root of x squared times y to the 5th power. We can combine it into a single radical house and put them as quotients inside. So x cubed y to the 9th over x squared y to the 5th. No? You're killing me, man.
Thank you.
You're killing me, Smalls. All right, here we go. Square root. Okay. Let's figure this out. I have 3 x's in the numerator, 2 x's in the denominator. So how many do we have left? 1 in the numerator or denominator? Numerator. So I'm just going to write x for now. What about y's? Y, I have 9 of them in the numerator, 5 of them in the denominator. How many do we have left? 4 in the numerator or denominator? Numerator. So y to the 4th power. Can we make any groups of 2 with x? Nope. X has to stay. Y to the 4th power. I can make 2 groups of y squared and y squared, right? You could take that out, or you could break it down further. I really don't care. That's a 4, not a y. Sorry. Right? I have 2 groups of y, so if they both come out, then it's going to be y times y, making it y squared. So that's why I said you can take out these instead of breaking it down further. Does that make sense? Okay? So I have y to the 2nd power, and then what's left is x. Okay? You guys doing okay? Okay, let's do number 4 because it has a negative, and I love those negatives and cube roots. Here we go. Do we have coefficients? Then what do we do first? Okay, so 28 divided by 4 is 7. So these 2 go first, and I put 7. And then now we get to put together our cube root, radicand, into one single quotient. So 3 cube root of negative 16m to the 6th power over 2m. What's negative 16 divided by 2? Negative 8. So this part right here is negative 8. And then right here, m to the 6th power divided by m. 5 left in the numerator, right? And then I have my cube root over that radicand, and 7 follows down. How are we doing? Am I going too fast? No. All right. Too slow? No. All right. I need negative 8, but they have to be identical bases. If they are different by sign, you cannot group them together. Okay? So if I say it's negative 2 times 4, does it make it up to a negative 8? Yes. Yes, but they're not identical. What 2 factors can I create with 4 that will be identical to negative 2? Negative 2 times negative 2 will allow me to have that identical piece. That would allow me to group those 3 together as one, right? So who comes out to play?
Negative 2.
Negative 2 comes out to play with 7. So 7 times negative 2. And what about m to the 5th power? All of it? I have m times m times m times m times m, right? How many groups of 2? Oh, no. Sorry, my bad. It's not 2. It's 3. How many groups of 3? 1 group of 3, so only 1 comes out to play, and the rest are going to stay inside as a radicand. So let's write that together equals negative 14m rad m squared, but this is the 3rd degree of radical. Let me try writing that again. Maybe it should be better. Ooh. I learned about this double tapping thing on my pencil. Yeah, it just figured it out. Because I thought double tapping meant this.
No.
Yep. Uh-huh. All right, is that better? Questions? As Nathan's dozing off, and it's recorded that I just stated that. I'm not editing, by the way. Do not have time to edit videos. I'm just going to upload it exactly as it is. All right, 48 divided by 6?
3.
3! Great job. So, square root of 3? That's it. How easy was that? So easy. You could have broken it down. I could have made it really hard by saying square root of 48 divided by square root of 16. But if you could simplify the radicals, why not? Just do it. Right?
4.
What? Are you serious? You want to do it that way? Sure. 4. Then what's in the numerator? Stop tapping. 12 times 4, right?
What?
12 times 4? And then 3 times 4?
4 3.
Yeah? Is 4 rad 3? Yes? Then we have no more of the 4s, and I'm left with rad 3. Same thing. Didn't you like what I just did better? Like, just going straight to that?
It's just an explanation.
Yeah. All right, here we go. Rad 3. Sorry, not rad 3. Cube root of 40 over 27, like I did before, we can break it apart. Cube root of 40 over cube root of 27. Why am I doing it this way instead of what we just did?
Because you can't divide 40 by 27.
That's it, okay? If we're not going to have like a nice and pretty whole number when we just simplify the quotient here, so break it apart when you can't do that, okay? So cube root of 40 is, I'm going to break it down, 4 times 10, 2 times 5, 2 times 2. So how many groups of 2s do I make with that? One group of 2, leaving me with 1 5. So I have 2 cube root of 5 over cube root of 27.
3.
No. Stop listening to Milo. Milo's all wrong. Thank you, Nita. I know. That's why I said don't listen to him. Fine. You're fine. You're fine. Okay. 2 over 3. Can I simplify? No. Can I simplify my index with the whole number?
No.
Please don't. But for some reason, you guys keep thinking that any numbers that match can be knocked down. Don't do it. Okay? We're not cherry picking what we can simplify. There are rules. All right, here we go. Yep, that's it. Cube root. Can I simplify 7 over 64?
No.
Can I simplify x to the 5th power over y to the 6th power?
No.
Nope. So we're going to have to separate these out into 2 separate radicals. Okay? And then cube root of 64, y to the 6th power. Okay? 7. Can I take the cube root of 7? Nope. Can I take cube root of x to the 5th power?
Yes.
Then what's left once I take out a group of 3?
X squared.
X squared. So I'm going to put x on the outside, cube root of 7x squared. How are we doing? I did go through that fast. Does anyone need me to break it down?
No, good pace.
Bro, come on.
It's a good pace.
Just expand it. Make a group. Then we're good, right? 2 on the inside, 1 on the outside. Here we go. 64. 8 times 8, right? 4 times 2. 4 times 2. And I can break 4 into 2 times 2 and 2 times 2. So how many groups of 2s can I pull out here? 2 groups of 2, making it 4. So I have 4. And then what about the y's? Y to the 6th power?
4y squared.
So I have 1, 2, 3, 4, 5, 6. So how many groups of 3 can I make? 2 groups of y's. So I have y squared, cube root. Oh, do we have any cube root? No, we don't. So we don't have to write it anymore. Is there anything else we can simplify now that we have everybody individually simplified?
No, that's it.
Awesome. Done. Oh, no, I erased it. Coming back. Here we go. Okay, questions? We're good?
Can you do the top one again?
Which part?
X to the 3rd root 7x.
Cube root of 7x to the 5th power. That one? 7 doesn't have any factors other than 1 and 7. We need 3 of a kind, right? 3 of identical kind. We don't have 3 of a kind with 7. So we leave 7 behind. But x to the 5th power has one group of 3, right?
Take that one out.
And then we take it out here. And then write down what's remaining inside as a radicand. Okay? All right, are we good? Now, all of these do not have radicals at the end in the denominator. Is that right? Nobody has radicals in denominator. There are none. Okay? When you have a radical in your denominator, you are required to know how to rationalize the denominator. Okay? Rationalizing the denominator means to get rid of the radical in the denominator. Okay? Because mathematicians are weird and they don't like it. Like the way they see 2 signs next to each other, they don't like it, so we change it. But we have to do this without changing the value of the rational. Okay? So meaning this. If we have monomial denominators, we just need to multiply the numerator and denominator, meaning a giant 1, okay, by the radical in the denominator. Okay? Meaning this. What's the radical in the denominator here? Rad 5. So you're going to use a giant 1 value of rad 5 over rad 5, so we don't change the value of it, but still be able to get rid of it. Okay? And this is how we get rid of it. Numerator, super easy. 3 times rad 5. I told you to treat this like what? The rad 5, what should we treat it like? Like an x, right? So this is going to be just 3 rad 5. Okay? You just treat it like an x, right? Like a variable. Then if I do 3 times a variable, I get 3 variable, right? 3 times a variable. So same idea. It's 3 rad 5. Okay? Denominator, we have 2. I'll write it out in black because that's the given part. 2 rad 5. And then we're going to take our rad 5 that we used in our giant 1, right? And when I do that, they can blend into one house. Like the way that we can blend quotients into one house, multiples of radicals can also be combined into the same house as long as they have the same index. Okay? Do they share the same index?
Yeah.
Yes. Then we have, I'm going to write down the 3 rad 5 in the numerator. Denominator is going to be, oh, don't simplify here, by the way. You don't want to cross these out. We're trying to get rid of the denominator's radical, right? So don't simplify there. We're going to do 2 times rad 5 times 5 in the same house. 5 times 5 is 25. Square root of 25 is 5. So if I end up with 3 rad 5 over 2 times 5, we got rid of it. We got rid of the radical, right? You just, no. Okay, let me say it again. How about I put in the middle step? All right, here we go. 3 rad 5 stays. 2 times 5 times 5 is 25. Rad 25. What's square root of 25? Austin?
5.
So I'm going to take my 2 and multiply by what I simplified this part with, which is 5. Then the numerator stays as it is. What's 2 times 5? 10. So my rationalized version of my solution is 3 rad 5 over 10. There's no more radicals in the denominator, therefore it is rationalized. Okay? Yeah.
If you multiply 2 radicals with the same index, will it become that same number as a
So what I'm saying is this. If we end up doing something like this, you can automatically say, instead of going through all these steps, you can just say, hey, that's rad 5 times rad 5. It's 5, if you simplify it, right? Because it's going to be 5 times 5. Square root of 5 is 5. If it's cube root, then it might be a different story. Okay? So are we good? All right. Here we go. Moving on. Number 10. Can I simplify 8 over 15? No common factors to simplify, so we're going to separate it out. Rad 8 over rad 15. Then what should I use to rationalize that rad 15? Meaning get rid of the square root sign. Right. Rad 15 over. Now keep this in mind. You have to show this step. I want you to know how to show this step. Okay, so you don't make a mistake of multiplying this by one single rad 15 over 1. It's not the same. Don't just put rad 15. Okay? So we have rad 8 times 15 over rad 15 times 15. Denominator is easy to figure out. What is it?
15.
15. And numerator is going to be a little more difficult. 8 times 15 is
40, 120.
320.
Wait.
It's 300.
Wait, 120 now.
okay. No, I'm laughing because I got such a low number than I expected. 8 times 15, Luna. Huh? 320? 120. Thank you. Sorry. 120. Let's break it down on the side here. 120. Okay, 12 times 10 is pretty easy. 4 times 3. 2 times 5. It's a lot of different kinds of numbers. Do we have 2 of a kind somewhere?
Yeah.
Where? 4. 2 times 2 would give me 1, 2, 3 identical 2s. Wait. That doesn't help. It doesn't, because we don't need the 2 there to be grouped. We just need these, right? So who comes out to play? 2. And then who's left over?
30.
We multiply each of the parts that are left over. 5 times 2 times 3.
30.
You could do 3 times 2 and get 6. 6 times 5 is 30. You can do 2 times 5 is 10. And multiply by 3, 30. Any way you want to make it, that's fine. It's 30 over 15. Can I simplify these two?
No.
Please don't. This is not the same as this whole 15. This one cannot be taken out from its irrational state. Okay? If you put in the calculator square root of 30, do you get same thing as 30?
No.
Then you can't do the simplifying with 15. Does that make sense? I hope it made sense. That's it. Okay, next page. Let's see. Is it this one or the next one? Okay, let's do this one. Number 11. What do I need to multiply with to get rid of my denominator of rad 7?
Multiply times rad 7 over rad 7.
Rad 7 over rad 7 will get me a giant 1, so that can be used to rationalize the denominator. Here we go. So 3 times rad 12 times 7 over 4 times rad 7 times 7. So what's 4? Well, rad 7 times 7 is 7. So 4 times 7 is what I have in the denominator. And then what about square root of 12 times 7? Got anything? I'm going to do that. We can put 84. We could break down 12 and then see if there's any matches with 7. Or we could just, it's up to you. However way you want to do it is fine. I like smaller numbers. I don't know about you. I love my smaller numbers. So I would just keep the 7 and then break down the 12. Does that make sense? Then do we have a pair of anything? I see a 2. And 2 can come out to play with 3 times 2 rad. And then who's left? Be careful. 7 and 3 are left, so we're left with 21. 3 times 2 is, oh wait, look. Do we have common factors that we can simplify here?
Yes.
Yeah, so let's simplify that. 2 and 4 can be simplified, and 2's left behind in the denominator, leaving me with 14 in the denominator, 3 rad 21 in the numerator. Did I go too fast there? Yeah, closer. Any questions? You sure? You want to try 12 on your own? Or do you want to move on to number 13 because I only have about 10, 25 minutes left? Do 12? Let's do 12 for the rest of the class. Yep. And this is like one class, right? One lesson. I didn't get to 2 with any of the other classes. I want to, but I don't think you guys are going to survive. Huh? Yeah. Well, let's do 12 and then I'll do 13 with you. Okay? Try number 12.
Try number 12, Nathan. You got another question?
Who has a question?
I don't know.
I'm just scared of it.
I'm just writing out all the steps though, in case I have people who are still kind of lost. Yep.
Why is it 32 times 2? 5 or 85 times 8? I think the very top.
Yeah, I'm just grouping the numbers together with letters, variables. I just grouped 32 times 2 and then 8 to the 5th times 8. So.
Where did the 2 come from?
Oh, it's 3. My bad.
Yeah.
Yes.
Is it?
Okay, that makes sense.
Yeah?
It's easier to simplify first and like actually do remove the stuff out and then multiply times 2.
What do you mean?
Like I simplified first and then I got this and then I multiplied. Because
What do you mean you simplified? Just the radical?
yeah.
Yeah, that's fine. Either way is fine. It's too purple. 96. 4?
Mom's a teacher, grandma's a teacher,
1. And then there's a pair right here. I have 4. Oh, where am I writing? Yeah? And then we have 4a squared because we have one of the a's here. And we're at 6 over 3. Okay. Any questions? You okay?
Do you recommend getting apple pencil?
What?
Do you recommend getting the apple pencil?
Yeah. I'm being able to show all the work that you guys can have automatically as soon as I'm done. I'm recording the video while I'm talking to you in class, as if you're in class, right? So, Uma.
No, bro.
Why is it a squared?
Oh, because right here, let me use a highlighter. Right here and here, I can simplify a over a. Okay? Anyone else? Okay, here we go. Square root of 8 minus square root of 2. Can I do that? You can't do that. So we have to rationalize it. Now, when we rationalize this, are you listening? Because it sounds like you're not. It sounds like you're still talking over me. All right, so square root of 2 over square root of 2 is how we rationalize number 13. But when we do that, we need to take this value and multiply by using distributive property. Okay, so when we have that, I get rad 8 times 2 minus rad 2 times 2 over square root of 2 times square root of 2 is 2, right? And then let's start simplifying. This one's easy to simplify. Square root of 2 times 2 is 2. Right? Over 2. And then square root of 8 times 2 is 16, right? Square root of 16 is 4 minus 2 is going to be 2 over 2, which is
1.
done. Craziness from all that work.
I love math.
Do you need to go potty? Oh, sorry, it got recorded. Go ahead. I'm recording the whole lesson right now. So here we go.
That's crazy, bro.
Okay, I'm going to multiply numerator and denominator by the radical in the denominator. Rad 12 times rad 12. Oh, is rad 12 simplifiable?
Yeah.
Square root of 12?
2 root 3.
Yeah, why don't we do that so we have smaller numbers to work with, right? So meaning this, if I were to simplify this, it's 4 times 3, right? And then 2 times 2. Then this would be 3 rad 2 plus rad 6 over 2 rad 3. Then I would not have to use 12, square root of 12, to multiply numerator denominator. I can use just rad 3, square root of 3. Does that make sense?
Wait, so we don't do a giant one?
I'm sorry?
We don't do a giant one.
That is a giant one right there. What I'm doing is that I'm making the radical in the denominator smaller, so that way I have a smaller number to distribute and multiply, okay? So I take my 3, square root of 3, multiply here and there, and we should get 3 times rad 6. Do you need me to spell out how I got 6?
No.
Okay. Plus rad 18 over 2 times square root of 3 times square root of 3 is going to give me 3. Okay. Then I have 6 in the denominator. 3 rad 6 should stay as it is, plus 18. Break it down. 9 times 2, right? So that means I can take square root of 9, which is 3, and rad 2 is what I get. Is there a factor I can factor out of the numerator?
3.
Is that simplifiable with the 6?
Yes.
So what we're going to do is factor that out. I'm moving this over so I have some more room. I'm going to factor out the 3 that they all have in common. Then we have rad 6 plus rad 2 over 6. Can I simplify 3 over 6 now?
Yes.
Yep. So that would be 1 over 2. So this would be rad 6 plus rad 2 over 2.
I got that.
Where?
Okay, I'm catching that.
Okay. Just replay it when you hear the video. All right, binomial denominators. Okay, I got 15 minutes, and this is going to be enough time for me to show you how to do this. Binomial denominators need conjugates. What are conjugates? Like for imaginaries, we have conjugates. Do you remember that they are not opposites?
If you have an imaginary, that's plus 2i, and conjugate's minus 2i.
Okay, so if I have 4 plus I, then what's the conjugate of that? No. It's 4 minus I. Right? It is not an opposite. It's a conjugate because it's just the last term that turns into opposite sign of that, right? Just the last term, not the first term, okay? So if I have a conjugate, number 1, okay? Step 1, for binomial denominators, you're going to multiply numerator and denominator by the conjugate of the denominator. Meaning this, here's an example. If I have 2 minus rad 3, what's the conjugate of that? Two plus rad 3. Does that make sense?
Was that only you? Or conjugate?
It's not opposite because the 2 would also have the opposite sign if it wasn't opposite.
Flip the sign.
Just change subtraction to addition, change addition to subtraction, but it does not happen with
Division or multiplication?
monomials in this case.
Mon.
Okay? Monomials, I just showed you how to do in so many different ways up till now. Okay? All right, so with radicals that have binomial denominators, we take the conjugate of the denominator and multiply top and bottom. Like that. Okay? So I have my 4 that I need to distribute to 4 and negative 2. Sorry, negative rad 2. Okay? So that's 4 times 4 is 16. Minus, remember to treat it like an x. The radical 2 is going to be 4 rad 2. Okay? We're going to put that all over. Product of these two binomials multiplied. Okay? When I multiply binomials, we can use FOIL or... Is your computer open again? Four plus rad 2 times 4 minus rad 2. What do I use? Not Xbox. That's for factoring.
Is it the box?
Box. We use the area model. Okay? So we take the 4 plus rad 2 times 4 minus rad 2, and we multiply. You can use FOIL if you want. I really don't care what you use in terms of multiplying binomial with binomial, but what you do want to do is make sure that you're multiplying correctly, okay? So 4 times 4 is 16. I'll do blue. 16. Then I have 4 times rad 2 is 4 rad 2. And then negative rad 2 times 4 is negative 4 rad 2. And the last one's going to be negative 2. Why is that?
Oh, because
Rad 2 times rad 2 is square root of 4, right? What's square root of 4? 2. Positive times negative is negative. Okay? What does this remind you of? Anybody? Nobody? Torture? Who said torture? Austin, was that you? Austin Van said that. Torture. All right, so we got identical radicals and opposites. They cancel out. Okay? Because they're identical, they cancel out. And then we got two whole numbers, 16 minus 2. We get 14. So what we get in the denominator is ultimately 14 there. No, it's not the answer. We got to do more simplifying. Okay? Can I factor out the numerator?
Possibly.
What can I factor out? 2 or 4, right? Why would 2 be better than 4 in this case? 4 can't simplify with 14, right? Even if I factored it out. But I can simplify 2 with 14. Yes? So if I factor out 2 from the numerator, and I write the rest as they are, then we have 14 in the denominator, which is 2 times 7, right? So if I simplify 2 with 14, I'm left with 7 in the denominator. So I have 8 minus 2 rad 2 over 7. Now it's at its lowest term. Okay? Questions? One more time? Okay. I could have used 4 for factoring out 16 and 4, right? But 4 is not simplifiable with 14. I'm going to have a leftover in the numerator and in the denominator with 4 over 14. So I'm going to factor out what I can simplify completely with the denominator, which is 2. So I use 2 as my GCF because I know I can simplify 2 over 14. Okay? Did you guys notice it's difference to 2 squares in the denominator yet? Yeah. Okay, so I'm going to try to compare this with A and B. A and B. This one's plus, this one's minus, right? Then if I have these two factors, what are they going to become? A squared minus B squared, right? So what's square of 4? 16. 4 times 4 is 16, yes? Okay. What's square of square root of 2? 2, yes? What's 16 minus 2? Do you see where we got the 16 minus 2 here? Do you see it? If you can figure that out and get straight into A squared minus B squared, do it. You could do the box anytime. Okay? It may be the long way, but you'll get there. Did you turn it off, please? Whew, you're the best. The grounder on the plug got broken off into the plug, and I didn't want to pull it out myself because I was scared that I would get zapped. And I just recorded that. I keep forgetting I'm recording. All right. So what should I multiply 16 with? What's the conjugate of 6 minus rad 5?
What do we do? Oh.
What's the conjugate of 6 minus rad 5? Yep.
What do we do?
Hold on.
Oh, wait,
I'm trying to shrink it.
Oh, okay, that confused me.
There. Okay. So conjugate of 6 minus rad 5 is?
6 plus rad 5.
6 plus rad 5 over 6 plus rad 5 is what we use. Distribute the 2 to the 6 and get 12. 2 to the rad 5 and get 2 rad 5 over. And remember what I just said? Please don't interrupt.
Attention students, if you did not finish your math state test today, please report to the library in the gym at the start of point break. I repeat, students who did not finish their math state test today, please report to the library in the gym at the start of point break. Thank you.
I'm trying to help you out with less steps. Unless you really want to do the box to help yourself, go for it. Go for the box, okay? So I'm going to end up with A minus B times the quantity of A plus B as difference of 2 squares. What's A squared? 6 squared. A squared is going to be 6 times 6. What's 6 times 6? 36. Okay? And then B squared is going to be rad 5 times rad 5. So what's that going to be? 5. So if I do 36 minus 5, what do I get? 31. So I have 12 plus 2 rad 5 in the numerator. Can I simplify with anybody in the denominator? Nope. 31's a prime, so you're done.
Wait, can you walk through the blue part?
Which part?
The light blue part.
Which light blue part?
Like from A minus B in the parentheses.
You see how A and 6 are the same for both? And rad 5 is same for both. So that's my A, and this is my B. A squared is 6 squared. Yeah?
Yeah.
So I get 36. B squared is rad 5 times rad 5, which gives me 5. So I'm going to take my 36 and subtract it by 5 and get 31.
I got the same thing with the Xbox.
Yeah, you get the same thing with Xbox. Okay? All right, you ready? One more, or do you guys want to pick 17 through 20? Which one? 20? All right, here we go. I think number 18 is harder, but we'll do 20. Are you sure? I don't mind. Okay. All right, then we multiply by the conjugate of rad 5 plus rad 3 is rad 5 minus rad 3. Rad 5 minus rad 3. Okay. Denominator's getting pretty easy now, right? Because they're identical, but in opposites. So difference of two squares. Then I would get 5 minus 3. Any questions on how I got 5 minus 3? Okay. 5 minus 3 is 2. Okay. Numerator is going to be 5 minus rad 5 times rad 5 minus rad 3. What do we use for that? What do we use for this? We should use the area model, right? So if we use the area model on that one, 5 minus rad 5 and rad 5 times negative rad 3, get 5 rad 5, negative 5, negative 5 rad 3, and 3 times 5 is 15. Negative times negative is positive, so I get rad 15. Any questions about any part of that box? Is there anything we can combine together? Nope. Then we write every single one of those out. Okay? I really don't mind any order. Just write 5 rad 5 minus 5 rad 3 minus 5 plus rad 15. Is there any GCF I can take out of all 4 of them?
5.
Nope. Last one does not have a 5 as a coefficient.
3.
Nope. None of them have 3 as a coefficient.
Oh.
So you have to leave it as it is.
Okay.
Okay. All right, your homework is on the next page. Okay. It's number 1, 5. What else was it? 1, 5. Hold on. 1, 5. Is it 9? I think 9. Let me double check. Sorry. Let's see. 7. Sorry. 1, 5, 10, 12, 14, 16. 1, 5, 10, 12, 14, 16. 1, 5, 12, 10, 12, thank you. 14, 16. I was so tolerant of you guys. I'm still recording. I'm going to stop.